Thank you, Tony. And next, welcome our moderator, Dr. Wei Kai-sun, to start our seminar. Thank you.
All right, thanks everybody. It's a great honor to be here. I've been attending CASPA events in different events in the past. This is the first time I join as a moderator / speaker talking to everybody. This is a great opportunity. And this has been mentioned a couple of times earlier, the importance of the EDA. That's the reason why we're here. Just real quick, when I started in the industry in the mid-90s, right, there's a slogan in the EDA industry that we are the enabler of electronics. And basically people find different ways to get a quote unquote respect, right? And the reason we're trying to get respect is because the EDA industry did it. Some of you being around for a while may remember in some of the late 90s, 97, 98, I think, one of the most important EDA conference DAC, the previous Cadence legendary CEO Joe Castillo have described the EDA industry as couple dogs try to steer a fixed amount of dog food. Not a pretty picture. So where we were to where we are today, we come a long way with system complexity. The various reasons the couple of speakers earlier mentioned already. Another obviously things that are happening with the geopolitical tension. Some of the technology by U.S. government imposed on China, for example, that's not a very positive event overall. But EDA made the list, right? And we got a lot of attention because again, we are actually the enabler of all the modern advanced electronic system we are designing today. So again, thanks everybody for coming in today. We have three interesting speaker and with the presentation followed by a panel discussion. The three speakers represent three of the top 4 EDA companies. So I'm hoping everybody can find something interesting there, and I'm hoping we can also have a very dynamic discussion. So without further ado, let me introduce our first speaker. JimmyCheng is the Chief of Staff at Synopsys. In this role, Jimmy is responsible for strengthening and expanding Synopsys EDA line of business, including design sign-off, physical verification, power analysis optimization, ECO extraction, characterization, memory analysis, 3D IC, design robustness, application. So basically a lot of stuff in Synopsys. Mr. Chen, before Synopsys, has held senior management role at Oracle, Spark Processor Design Division. Mr. Chen has over 20 years industry experience, including Sun Microsystems, NASA Jet Propulsion Laboratory, and he holds a Master of Science degree in EE from Stanford. Welcome, Mr. Chen.
Thank you, Wei. Okay, shall we get started?
Yes, please. We have, so Jimmy, I have not seen your, okay, there we go. Come. Go ahead.
All right. Is everything clear on the screen?
Yes, it is.
All right, thank you.
Looks like we lost Jimmy.
Yeah, I'm back. My Zoom crashed, but I'll be back. Yeah, let me try it again.
That was quick. Go ahead.
Okay, is everything okay here?
Yep.
All right, thank you everybody. All right, good afternoon and very warm welcome to CASPA SIG event. Thank you for the organizer and audience. My name is JimmyCheng, Chief of Staff of Synopsys. Very honored to be invited for this special EDA focused CASPA seminar. I'll be talking about how Synopsys is innovating from atoms to systems to unleash the opportunity in the upcoming SISMO era. So as we gather to discuss about challenges and opportunity in EDA, we have just witnessed the power of AI that unleashed upon us an example of ChatGPT. I want to highlight some role of innovation in this field and the potential of AI to drive it forward. EDA has been the forefront of technological innovation for decades, enable engineers and designers to create complex electronics systems with greater efficiency and accuracy. However, as the complexity of design continues to grow, the demand for faster time to market increases. It's clear that we need new approaches to tackle those challenges. This is where AI comes in with the ability to lean on the vast amount of data, identify patterns and insight that human might miss. AI has the potential to revolutionize EDA. From automating repetitive tasks to improving design quality and reduce error, AI can help us achieve new level of efficiency and productivity. ChatGPT is a great example of how AI can be applied to natural language processing, but the possibility of AI in EDA is just as exciting. Imagine a world where EDA tool can be automatically generated, optimized design based on user requirement, or where a designer can use natural language input to create complex circuit without needing in-depth knowledge of underlying technology. Here is Synopsys, a leader in AI research in EDA. We're proud to introduce you some of the latest AI innovation in EDA. For example, our revolutionary AI product for chip design called DSO.ai have just completed 100 tape-out, a truly astonishing accomplishment considering we just released a product not too long ago. So let's use this seminar opportunity to learn and from each other, share our experience and insight, and explore the potential of AI to transform EDA in the upcoming SISMO era. So these days, every company is evolving to be a tech company, embracing software as a way to drive new differentiation to their offering, delivering new and innovative user experience. What makes this possible are the underlying chips in which the software runs. When both those disciplines can be deployed in a coordinated, optimized way, great product and great companies are created. So here are some examples of traditional companies embracing software-driven transformation to deliver a higher value and differentiation for their customer. Companies like Starbucks, companies like Caterpillar, are all embracing software mindset in order to improve the performance of the product and the value they're delivering to the customer. I think we're all familiar with the trend. System companies are differentiating with custom silicon. They design in-house. The technology becomes core to their business. So silicon development is brought in-house. Many of the companies have no presence in semiconductor market just 10 years ago. And today they are a major consumer of chip capacity, a truly remarkable transformation. It is a significant accelerated the overall momentum in the semiconductor industry. It's one thing to develop custom silicon, but a real force multiplier is achieved when software application and the underlying chips on which they run are co-optimized. Several companies are now actively optimizing at the intersection of software and hardware to deliver this unprecedented system-level performance and dramatic user experience. The whole revolution around AR, VR, or the amazing experience you got from your smartphone these days are a great example of those phenomena. So let's now examine how market dynamics are changing. For the past several decades, the 2x every 18-month scaling delivered by Moore's law served to address innovation demand of industry. If you could imagine your design to if you could migrate your design to next technology node, you would enjoy lower power, high performance, lower cost due to smaller die size. Technology supply innovation demand will balance due to a large part of process innovation delivered by the foundries. As we approach current decade, we continue to see impressive density scaling, but power and performance are not scaling as before. Migrating to next process node is more complex and expensive, and the performance power area benefit are not as dramatic. Why Moore's law has slowed down a bit. The widespread deployment of smart everything across many industries is causing innovation demand to remain on the same exponential curve as before. As we now see a gap between the traditional Moore's law progression and the innovation demand. So how do we close this gap? New technologies and approaches are needed to keep our technology progression curve going with the same gain as before. We've referred to this ambition curve as SISMO, where scale and systematic complexity meet. In SISMO era, design companies make several choices on their technology and business strategy around key disruption area. For example, the approach to multi-dice design. For the application of cloud AI for the engineering workforce to overcome the engineering talent shortage. Design team across industry have to make many of the decisions very quickly in order to achieve the fullest ambition in the upcoming SISMO era. As we speak to the semiconductor executive across industry, there are 5 overarching themes that we keep hearing repeatedly. These themes all require us to solve problems in a wide-ranging or holistic way. The first one is performance per watt is everything. Whether you're defining or designing next generation CPU, GPU, the next TPU, you need to optimize power from the software to architecture to silicon. And you really need to look at it from an end-to-end approach so that it can deliver the best performance while the desired workload on which the process should be optimized. Second, executives across spectrum are very concerned about shrinking market windows and the importance of first-time right silicon. We also call this A0 to production. How do we make sure we can ship left as much as bug finding as possible and really have zero bug escape at the very end? All this enabled by modern, robust verification methodologies that's up to date with latest method and technologies. Third, the move to multi-die and 3D systems. This transition is absolutely happening right now. The industry is transitioning to 3D IC, different forms of way integrating dies together in the same package, also stack dies on top of each other in order to achieve the best performance, the best cost, as well as to address rising systematic complexity. Fourth, the importance of safe, secure, resilient silicon. The phenomena of safety, security, resiliencies have to be optimized across design lifecycle, all the way from design phase to manufacturing, all the way through in-field operation. The importance of mean time to failure and maximizing mean time to failure is very critical for applications that need constant uptime. Last but not least, we have to solve this challenging environment where there is severe engineering talent shortages affect us across industry. So how do we dramatically improve the productivity of our engineer and therefore enable them to do more than what they have been doing in the past? This requires us to enable rapid application of AI and cloud, modern method to significantly improve productivity of engineer, as well as to rapidly ramp up engineering talent that they are acquired from across ecosystem. So let's start with first thing. Performance per watt is everything. In order to deliver the best performance per watt, Synopsys made a significant investment in delivering Fusion, the industry's next generation design environment. We took our synthesis, place and route, sign-off technology, fused them on a common data model, which then enable us seamlessly move from those technology across a full flow, thereby delivering a powerful new environment for RTL to GDS design. Fusion delivers the best PPA in the industry in a highly convergent flow, eliminated margin, which is the band of a PPA. All this while delivering the fastest time to results. We then augment the fusion with AI. We're excited about the success we're seeing with DSO.ai. Our AI system sits around fusion, then optimize the larger design space in terms of flow, in terms of parameter, in terms of library cell selection, design hierarchy, really looking at a broader solution space than what the fusion will look at a given set of collateral, whereby achieving the best possible PPA that's possible. Our results with DSO has been presented at several industry conferences. The basic idea of AI engines start sampling the design with several rounds to understand the true characteristic. Then it horns in where the best PPA lies and delivers the efficient frontier we're seeing there. Further, we can learn from those rounds, thereby having successive revision of the design and optimize with learning, therefore converging even better PPA in a much more accelerated, less compute-intensive workflow. So this combination of Fusion and DSO.ai is delivering the best PPA, best time to results in the industry, has been broadly adopted across industry to deliver all the next generation silicon being developed at all leading customers. When we talk about performance per watt, the importance of having an end-to-end solution to optimize and measure power is very, very critical. Power is not something can be optimized late at the end of project cycle. We have to look across the entire spectrum, ranging from software architecture, RTL implementation, sign-off, and even post-silicon. Synopsys has assembled a strong lineup of technology across spectrum, ranging from platform architect for architectural level exploration, ZBoolean power for very high performance power profiling, very strong RTL power analysis technology, fusion compiler to optimize power to give the best possible PPA, then prime power, which is the industry standard gate level power analysis sign-off platform. So this end-to-end solution, all the way from software to silicon, is really the Synopsys approach. We're seeing a lot of traction across the industry, delivering the best possible performance per watt for our customer. The next big thing in shrinking market window, and important getting first time right silicon. It's very important to look at the verification methodology and evolve them to the latest and greatest method. In order to achieve this goal, we have shift left, finding bugs into the design process, minimize number of bugs, escape and slip at the very end. In order to do this, we have invested significantly, bring AI into verification in a major way. If we consider traditional coverage flow, closure flow, verification engineers are manually define coverage and stimulus, running 1,000 regressions with unknown ROI. And after collecting coverage, manual analysis, an enormous amount of data leads to minimal insight. And in order to close coverage test, it has to be manually biased, and directly test have to be written, which is labor intensive and slow. So introducing VSO.ai, which is applying AI technology to the entire loop. First, using AI to infer coverage, then targeting stimulus and automatically biasing test to hit hard to hard hit coverage, optimize the regression so higher ROI tests are run first, and apply AI automated analytics and define prescribed insights. So let's move to third thing, the industry transition to 3D IC. We absolutely see transition from system chip to system of chip, system on chip to system of chip. There are two types of 3D IC design being done in industry. The first one is called disaggregation, a traditional monolithic design getting partitioned into different dies, then brought them together into a single package in order to optimize costs, as well as deal with larger scaling requirements. At the other end of the spectrum, we have integration, where designs which were traditional different chips now coming together on the same package. Very often different process in order to deliver combined system in a single package. This is more driven by PPA requirement. On HPC, AI, mobile side of the world, we see more and more disaggregation trend. On the networking, co-packaged optics and other side of requirement, we see the integration side of trend. So 3D IC is absolutely here, it promised offered a whole bunch of new exciting possibility for our industry. As a synopsis, we have introduced a unified platform for 3D IC exploration design, as well as sign-off analysis, all in a single cockpit, whereby enable multi-die, multi-technology, multi-discipline, and multi-team. This is the environment where SPI engineer can do analysis as much as a designer that is looking at take their monolithic design and break it into multiple dies, as well as STA engineer that's looking into a multiple die STA of their design. So really want to have a single unified cockpit that enables all the different types of engineer to looking at the same view of the data, looking at different abstractions, keep things consistent, whereby having a convergent smooth workload to design very complex design, which is systems of chip, all on a single package. In order to achieve this, 3D IC Compiler really enables three types of capability. The first is exploration, where you can do rapid what-if analysis with respect to looking at different type of multi-die configuration for your design. The second is design implementation. Once you have frozen the type of configuration, you want to go forward with it. How do you make connections between dies in a very efficient way? How do you do the bump planning? How do you do TSV insertions? How do you do all the connections, all the pings, the most efficient way? And then last but not least, all this has to happen with a backplan of sign-off or multi-physics analysis available. And with our partner ANSYS, we have an industry-leading portfolio of sign-off of multi-physics analysis, all available within this cockpit to enable rapid sign-off analysis as well as what-if exploration. So let's now move to silicon robustness. And a couple paper published by Facebook as well as Google talks about the fact that silent data corruption are happening in the data center in a big scale. And when you run very, very large data center with tens of millions of servers, having even a few percentage of cores that essentially fail due to whatever reason can cause a major disruption with respect to uptime that can be guaranteed to applications. This is increasingly become a major issue. And therefore, the importance of a very resilient, robust silicon that is a foundation of those data centers become front and center, a critical problem to solve for the industry. So now, how Synopsys address the challenges of silicon robustness? So how do we do this? We're first starting by embedding on-chip monitor, sensors like PVD sensors, path monitors, onto the design. The data from those monitors and sensors are processed locally within the chip, and certain actions are taken, like, for example, voltage and frequency scaling, temperature throttling. And it can be brought up the chip to high-speed interface in order to process data in aggregate to optimize overall functioning of the design across all the phases. So one of the challenges to the engineer's productivity is compute. Across industry, as we do advance, node designs and chips are getting more complex. Routinely, we hear about engineering teams being severely constrained with respect to compute, running out of compute capacity, which then impact our time to market, which then impact the schedule. In addition, there's a lot of new technology that EDA, which uses things like GPU or FPGA for acceleration. The availability of this type of new hardware is also posing a challenge in the on-premise setup. Further, the latest processor, latest memory to get the best possible throughput is also something that has a very, very long lead time. Last but not least, for a small group that's starting up or small group in a very large company wants to experiment, EDA flow become increasingly more and more complex, which then becomes a huge barrier to adoption to those who are looking for rapidly prototype an idea or small company trying to get off the ground without needing assemble a lot of experts to build a full EDA flow. So these are some of the challenges being faced productivity front related to compute as well as flow complexity. Here's a summary of Synopsys cloud offering. The first offering essentially built on the customer already doing today to burst to the cloud. Essentially, it's called BYOC, bring your own cloud option, where Synopsys can help customer essentially take their flow, essentially burst onto cloud. And all major cloud providers supported. The big innovation is really flexible business model enable pay-per use for customer may be interested. The second offering is a Synopsys software as a service offering. Essentially lower the barrier to EDA adoption by small groups, really cannot have a big upfront investment of expertise, people, compute, to build up a full EDA environment. The Synopsys SaaS solutions support all key franchise in design verification as well as analog layout, and the promise to be exciting new way for designer to access EDA in very frictionless manner. Last but not least, our emulation platform, ZBoost, is also available through the Synopsys cloud offering. So let me finally close with a few observations. We are entering SysMall era at a time of unprecedented industry growth. Truly an exciting time for industry and Synopsys. Synopsys innovation we covered today addresses PPA and CT, which is cost, time to results, zero risk-bin, multi-die integration, reliability, robustness, safety, and SLM. These are all important economic disruptors as we transition into SysMall era. The combination of fusion with AI, the availability of cloud solution, all those scales engineering productivity and help industry cope with next sets of challenges which SysMall era is going to bring up us. Thank you, and thank you, CASPA, for all your attention, and take care.
All right, thanks, Jimmy. Pretty comprehensive overview of Synopsys offering. Being one of the top EDA companies, the whole Synopsys solution has a decent representation, because I'm biased, I'm from Synopsys too, but has a decent representation of what the industry facing. Thank you.